Now this is two curves here. This is a little bit different. It's about the x-axis. After I finish this, you try 20. It's about the y-axis. And you can do the same thing as I did before. You can swap the letters here and do it about the x-axis. So it becomes the same problem as I have in 19. Well, I guess I'm doing 22. Same kind of thing. I've got two functions. I've got y equals x cubed and y equals 1. I'm swinging this around y equals minus 3. So what's different here? In the previous problems that you just had, you're going to be swinging it around a shape around y equals 0. So you're going to have a hole inside it. Here, you're going to have a bigger hole. That's what's going to happen. So I've got this blue shape, and I literally, you can see the fold in the paper because I had to it's too far away. If you were doing number 20, you would be folding it right at y equals 0, and the shape would be there, and you'd have a smaller hole. Now I'm going to have a larger hole because it's like I'm swinging it around y equals minus 3. That is what I'm doing. So what I literally did, I did folding over, and I scratched on the paper, and I drew the shape below it, and you see the blue mirror image. So what I have, if I swing that around, is I have a gigantic hole. And I know even the length of that radius of that hole, it's all the way up to the y equals 0 and one more. It's a radius of 4. So it's like I have a cylinder punched out of whatever shape is going to ensue. I did my best to draw this shape with, if I didn't have the hole, I would get a horn, a big gigantic horn, but then I have to throw out this hole. I can tell you that the picture starts at x equals 1 and ends at x equals 2 because they gave me that. All right, so how do I deal with this? Well, I'm just going to start with the big horn first. The total cross section is, without the hole cut out, the radius is going to be 3, because I have to reach the x-axis, and then I go from the x-axis up to the curve. So up to the curve was x cubed. The distance from 3, it's going to be 3 up to the x-axis, and then a little bit more, x cubed. So this is my radius. It's the distance from minus 3 to 0, which is 3, and then the function, x cubed. So the total volume of the hole is going to be pi r squared again, but my r is now 3 plus x cubed squared. And that's a squared there. It looks funny. It looks like a cube, but it's a squared. And my a to b goes 1 to 2. Now I have to find the area of the hole. The area of the hole is going to be this distance I pointed out earlier. I'm going to have a r of 4 because the hole starts at minus 3 and ends at y equals 1. And so that r is going to be 4. So the volume of the hole, the way I've been showing you in class is say, hey, that's a cylinder. Maybe Carly's 3rd grade class teacher probably showed her what the volume of a cylinder was, but you can also do it by integrals. The radius is 4, pi comes out, you do the integration, you get 4 pi. So the volume of the hole is 4 pi, and you just take the original total volume of the horn and throw out the hole. So you try number 21. It's a little bit easier because you're not going so far as minus 3. It's around y equals 1. So you're swinging that thing around higher. If you have trouble with this, let me know, because that one's going to be hard, a little bit harder.